Okay, so the next few segments I want to spend talking about NoSQL. And so these systems are typically associated with building very large scalable web applications as opposed to analyzing data, which is really the focus of this course. However, I think it's important to cover this topic for a few reasons. One is, as a data scientist, you'll be manipulating data that is increasingly found in one of these variants of a NoSQL system. But also the systems and the terminology in this space are really influencing people's thinking about how to deal with large-scale data. And so being cognizant of the landscape here and being cognizant of the major trends in the history allow you to make informed decisions about this. As a data scientist, you may be asked to make recommendations about what kind of platform to go with to do your analysis. And so understanding the pros and cons of some of these systems and how they work can be pretty important. Okay. And then maybe third, the same concepts that we've been discussing in other segments, sort of relational algebra, logical data independence, simple analytics going a long way, simple scalable analytics, indexing. These ideas come up in this space as well. And so it's yet another application of these concepts. And then maybe finally, the data scientist may be called upon to actually build some of these large-scale systems as part of their work. It's not unheard of. I mentioned in the first few segments that building data products was an important part of data science, and so one manifestation of data products is some of these large-scale web applications. Okay, and so NoSQL systems may or may not be a part of that. Fine, so let's get started. All right, so where we are so far is we've mentioned that data science maybe has these three steps: data preparation at large scale. All right, and we've talked about manipulation and munging and data jujitsu and so on, and that's all this step one. And then step two is analytics, or actually running the model, and we're going to get to that in the next week. And then third is communicating the results, interpreting and communicating the results, and this will be, visualization will be a big part of the way we talk about communication. Okay, so we're still in this data preparation phase, and we're spending a little bit longer on that than, say a third of the course, more than a third of the course, for the reason that I gave in the first few segments, that really this is the part that keeps people up at night. So I want to make sure that you're armed with how to use databases to do this data munging, how to use MapReduce to do this data munging. Also make the point that a lot of times even the analytics itself can be pushed into these systems, which you saw in hopefully in assignment 2, in the database assignment. Okay. So then some of the key ideas from databases that we took away were this concept of the relational algebra comes up even outside of databases. It's not only found, with SQL systems, and we'll see that again. And this notion of physical logical data independence comes up over and over again. Maybe indexing. And then we talked about MapReduce, and we gave a lot of examples of some basic operations in MapReduce, and we started an assignment involving writing your own MapReduce programs, at least at the programming model level. And so here we saw that part of the advantages of the system itself, first at Google and then in the implementation Hadoop, was fault tolerance at scale. And another one was you didn't have to load the data. You could just work with it as is, unlike databases where you have to actually impose some sort of a schema on it in order to even touch it for the first time. And so that first step can be a doozy. Okay. Extending this point, direct programming on in-situ data. So anything that comes at you, you can if you can write a program that can process it, you can probably write a MapReduce program that can process it at scale. Right? And that's a very, very powerful thing. All right. Maybe another way to put this is sort of single developer, right? You're kind of up and running within the hour with MapReduce, and that was never really a property that databases had. It was always a sort of difficult, it was a significant project to get a database installed and running. Fine. So that's the background, but what we haven't talked about is this NoSQL system. And so I want to use this table as a way to sort of organize the roadmap for this discussion. And so what I've done here is tried to list out by feature a bunch of relevant systems in this space. And right now they're sort of sorted by time. And so these features are admittedly selected by me for what the important ones are, but I don't think they'd be too controversial, and I don't think there's anything obviously missing here either. Okay, so going through these briefly. Then a major one here was that it needs to scale to sort of thousands of machines. Then there's some need to look up by a primary index. What I mean by that is by some key value, right? You can look up by some record identifier. Okay, and then another feature that they may or may not have is the look up by secondary indexes. So what I mean here is you can look up by some attribute that is not that key. Okay, and so databases have this, for example. You can build an index on any attribute you want, and the optimizer will take advantage of it. The third one, and this is the one we'll spend a lot of time on because it's sort of pretty fundamental to the motivation for why NoSQL systems sort of earn their own moniker or are different, are transactions. Okay, and you can also see that there's some complexity here that I'll try to explain as we go through this. So it's not just a yes or no, it's kind of depends on the case by case. Okay, and then this field is whether or not these systems support essentially joins, but I've generalized that to analytics, and I'm perhaps guilty of making those two things almost synonymous. If you can do joins, then there's a whole space of different kind of analytics things you can do, and if you can't do joins, then you're leaving all that work up to the client, and all you can do is retrieve data. And so that's really a key indicator of how much computation you can push into the system and how much you have to sort of bring the data back out to the client. Okay. And then integrity constraints, and I debated about calling this schema instead of integrity constraints, but as I think we'll see, arguably some of these systems do indeed have a schema, but may or may not actually enforce that schema. And so it's, just to avoid the confusion, I'm going to call this integrity constraints. So this is sort of hard schemas, if you will. Okay. And then views, which if you remember is I'm declaring that to be synonymous with logical data independence. And then finally, is there some sort of declarative language or algebraic way of programming against this thing, or is it really just sort of a low-level, simple operation API? Okay. All right, so a couple of caveats here. One is I haven't included any parallel databases on this list at all, although there's absolutely no reason why you couldn't include them here. They would tend to have a lot of check marks across this row. But since the focus is NoSQL systems, I am leaving those out. And then the other caveat I make is that individual cells in this table may be debatable depending on how you interpret the column. So this isn't necessarily meant to be hard and fast rules, but again, I don't think they'll be wildly controversial either. Okay. So one of the first stories you can tell by staring at this table is that relational databases, have been around for quite a while and have check marks sort of everywhere, have all these features, except they weren't really ever shown to scale to lots and lots and lots of computers, right? Everything was sort of on the order of tens of machines. Okay, so why don't they scale? Well, we talked in the MapReduce segment about sort of read performance and related, and sort of analyzed some experimental results from a paper in 2009 comparing sort of the benefits and strengths of MapReduce versus databases. So maybe on read performance there's an argument to be made that they did scale, but one area where they certainly didn't, or at least certainly weren't shown to scale to this level, was in updates. Okay, so not just the read and not just the analytic workload, but the transaction processing workloads. All right.